Data and information collection for risk-based inspection, RBI, gathering essential data to support risk evaluations. Introduction to RBI data and information collection, purpose and role of data in RBI. Data and information collection form the foundation of any effective risk-based inspection, RBI, assessment. The primary purpose of this stage is to gather reliable, relevant, and sufficient information to support informed decision-making related to equipment integrity, inspection planning, and risk management. In an RBI framework, data is not collected in isolation, rather, it directly supports the identification of credible damage mechanisms, potential failure modes, and realistic failure scenarios. These outcomes are critical inputs into subsequent RBI steps, including probability of failure, POF, consequence of failure, COF, and risk ranking. A well-structured data collection effort ensures alignment with the objectives, boundaries, and level of detail defined earlier in the RBI process. The quality and relevance of the data collected influence the confidence level of the assessment results and ultimately affect inspection intervals, inspection methods, and mitigation strategies. Inadequate or poorly understood data can lead to incorrect assumptions, underestimated risks, or overly conservative inspection plans that increase cost without improving safety. Another essential role of data in RBI is its contribution to consistency and repeatability. When data requirements are clearly understood and standardized, RBI assessments can be updated over time and compared across units, systems, or facilities. This consistency supports long-term asset integrity management and continuous improvement. Additionally, effective data collection enables cross-functional collaboration among inspection, operations, corrosion, process engineering, and management teams, ensuring that technical, operational, and business perspectives are all reflected in the risk assessment. In summary, data collection is not merely an administrative task but a strategic activity that underpins the credibility, accuracy, and usefulness of the RBI program. A disciplined approach to collecting and understanding data is essential to achieving the core RBI objectives of managing risk, ensuring safety, maintaining reliability, and optimizing inspection resources. Typical data needs and RBI methodologies. RBI assessments require a broad range of data that collectively describe the equipment, its operating environment, and the potential impacts of failure. Typical data needs include equipment type, materials of construction, inspection and maintenance history, operating conditions, process fluid compositions, damage mechanisms, corrosion rates, safety and detection systems, and cost-related information such as business interruption, equipment replacement, and environmental remediation costs. Each data category contributes to building a comprehensive understanding of risk from both technical and business perspectives. The level of detail and precision required for these data elements depends strongly on the RBI methodology selected. Qualitative RBI methods rely on broad data categories and ranges, using engineering judgment and experience to rank risks. These methods typically require less detailed data but demand a high level of user expertise to interpret generalized inputs consistently. Semi-quantitative RBI methods bridge the gap by using similar data types as quantitative methods, but with less precision. Estimates and categorized values are often acceptable, allowing for a balance between analytical rigor and practical effort. Quantitative RBI methods, on the other hand, require detailed, high-quality data to support logic models, physical consequence models, and probabilistic calculations. These methods evaluate combinations of events that may lead to failure and assess how hazards progress and impact people, the environment, and assets. As a result, quantitative RBI places greater demands on data accuracy, completeness, and validation. Understanding the relationship between RBI methodology and data requirements is critical for efficient data collection. Collecting excessive detail for a qualitative study wastes resources, while insufficient detail for a quantitative study undermines credibility. Therefore, defining the RBI approach early and aligning data collection efforts accordingly is a key success factor in any RBI program. Importance of data quality in RBI assessments. Data quality has a direct and significant impact on the accuracy and reliability of RBI assessment results. Regardless of whether a qualitative, semi-quantitative, or quantitative approach is used, poor quality input data can lead to misleading risk rankings and inappropriate inspection decisions. Common data quality issues include outdated drawings, incomplete inspection records, clerical or transcription errors, and limitations in inspection techniques or measurement accuracy. One critical challenge in RBI data quality is the use of assumptions, particularly when historical inspection data are missing or incomplete. For example, assuming nominal wall thickness in the absence of baseline inspection data can significantly distort calculated corrosion rates, especially early in equipment life. Measurement scatter and uncertainty can also create artificial trends that mask real degradation or exaggerate deterioration. Without proper validation, these issues can result in either underestimated risks or unnecessary inspection frequency. Data validation is therefore an essential step in the RBI process. Qualified personnel, such as inspectors, corrosion engineers, and process engineers, should review and confirm key data inputs and assumptions. Validation activities may include comparing inspection results with expected damage mechanisms, benchmarking against similar equipment or industry data, and applying statistical analysis to identify outliers or inconsistencies. Process upsets, operational changes, and management of change (MOC) records should also be reviewed to ensure that data reflect current and realistic operating conditions. Ultimately, investing time in data quality and validation reduces uncertainty, increases confidence in RBI results, and supports more defensible inspection planning decisions. It also helps dispel the misconception that RBI is overly time-consuming by preventing costly rework caused by poor or unreliable data. Influence of codes, standards, and site data on RBI. Codes and standards play a crucial role during the RBI data collection stage, as they define inspection requirements, acceptance criteria, and evaluation methods that directly influence risk outcomes. An RBI assessment should identify which national and international codes and standards are currently applied for in-service inspection and evaluation, as well as those used during original equipment design. Differences in code requirements can significantly affect assessed risk levels and inspection strategies. Common industry standards such as API 510, API 570, API 653, and related recommended practices provide guidance on inspection intervals, methods, and fitness for service considerations. In addition, process-specific standards may apply depending on the service environment, such as standards addressing high-temperature hydrogen attack, sulfidation, amine systems, or hydrofluoric acid service. Understanding and incorporating these requirements ensures that RBI assessments remain technically sound and compliant. Equally important is the collection of site-specific data, which provides context beyond generic industry guidance. This includes design and construction records such as PIDs, process flow diagrams, material selection documents, inspection and repair histories, corrosion control documentation, process data, hazard analyses, and reliability studies. Site conditions, including climate, weather exposure, and seismic activity, may also influence degradation rates and failure consequences. By integrating applicable codes, standards, and site-specific information, RBI practitioners can tailor risk assessments to the actual operating environment. This approach improves the relevance of risk rankings and supports inspection plans that are both compliant and optimized for the specific facility. Best practices and key factors to successful RBI data collection. Successful data and information collection for RBI relies on a structured and disciplined approach. One of the most important success factors is clearly understanding the data needs before collection begins. This includes defining the RBI objectives, selecting the appropriate methodology, and identifying the level of detail required. Without this clarity, data collection efforts may become inefficient or misaligned with the assessment goals. Identifying appropriate and reliable data sources is another critical factor. RBI data typically comes from multiple departments and systems, including engineering, inspection, operations, maintenance, process safety, and finance. Coordinating across these functions ensures that all relevant technical, operational, and cost-related information is captured. Once collected, data must be systematically reviewed to verify quality, relevance, and consistency. Discarding poor quality or unreliable data is equally important. Using questionable data can be more damaging than excluding it, as it may create false confidence in the results. Where data gaps exist, assumptions should be clearly documented, justified, and reviewed by qualified personnel. Software-specific data requirements should also be identified early to avoid delays or rework during analysis. In conclusion, effective RBI data collection is achieved through understanding requirements, leveraging the right sources, validating quality, and maintaining clear documentation. These practices enable RBI programs to deliver reliable risk insights, support defensible inspection planning, and contribute to safer and more cost-effective asset integrity management.